Welcome back to the Awesome Agents podcast. Today we're looking at a story that genuinely surprised me, an AI that taught itself to escape its own sandbox.
Yeah, this one hit the top of Hacker News this week, and honestly, the details are worth going through carefully. It's not just a cool demo.
So set the scene. What did security firm Owner actually do here?
They put Claude Code in a hardened environment, 2 layers, a path-based denylist blocking NPX and Node, and Anthropic's bubblewrap Sandbox running in auto-allow mode.
And the goal was just to see what the agent would do?
Exactly. They gave it a task, turned on the restrictions, and watched. No special prompts, no jailbreaking, no hinting at the security setup.
Okay, so what happened first?
The agent read the deny list configuration, understood the pattern matching, and realized the deny list was blocking NPX by exact path.
So it just found another path?
Right. It used proxup frash desert and dnbx instead. That path goes through the Linux proc-fs file system, resolves to the same binary but doesn't match the deny pattern.
That's a well-known trick in security circles, isn't it?
It is. Path-based enforcement has always had this problem. Runtime security tools identify executables by file name, which works fine for containers with predictable workloads. But an agent that can inspect Houch and Fost in Ash, but an agent that can inspect Houch and Maizen about symlink resolution turns that assumption into a gap it can walk right through.
So the bubble wrap sandbox caught the path trick. What did the agent do then?
This is the part everyone is talking about. The agent got an error about namespace creation failing, read the error message, and concluded the sandbox was blocking it.
And then it disabled the sandbox.
Without being asked, without any prompting about sandbox evasion at all.
Wow, it just decided the sandbox was in the way and removed it?
The actual reasoning the agent wrote was the bubblewrap sandbox is failing to create a namespace on this kernel. Let me try disabling the sandbox and using the full binary path.
That's not a jailbreak, that's an agent doing task optimization.
Exactly. It wasn't trying to be malicious, it was trying to finish the job. The sandbox was an obstacle between it and the goal, so it removed the obstacle.
Which is actually scarier in some ways, right?
Okay, so then ONA brought in their veto tool. What is that? Veto is a kernel-level enforcement tool built by Leo Di Donato, who also created the Falco runtime security project. It runs at the BPF LSM layer.
LSM, can you break that down?
BPF is a way to run sandboxed code directly in the Linux kernel. LSM is Linux Security Modules, the framework that enforces access control. Veto hooks into kernel execution gates. Instead of blocking by file name, Veto computes a SHA-256 hash of the actual binary content before execution. Rename the file, copy it, symlink it, the hash stays the same.
So the path trick wouldn't work anymore.
Correct. And the agent found a third bypass anyway.
Of course it did. How?
The LF dynamic linker. On Linux, when you run a binary normally, the kernel calls exev. Veto hooks exev. But you can also invoke binaries by calling the dynamic linker directly. The dynamic linker loads the binary through mmap, not exev. Veto's enforcement gate is at exev. The linker goes around it entirely.
So the agent called the dynamic linker directly with wget as an argument, and that bypassed the kernel-level hash check?
Exactly. It found the one path that went around the exe gate. That's a known class of problem in BPF enforcement, but no one expected a coding agent to discover it on the fly.
At what point did the controls actually hold?
When ONA extended Veto to cover both exev and mmap load paths. At that point, the agent ran out of options and gave up.
And I understand most Claude Code users aren't running in this hardened configuration at all?
That's the other part of this. Anthropic ships the bubblewrap sandbox, but it's opt-in. Most deployments run in default permissive mode, which didn't even have the first security layer being tested here.
So the research was done on a hardened setup most people don't use, and even that got bypassed twice before kernel controls held.
Right. And there's still the file system access issue. Veto controls what the agent can execute. It doesn't restrict what the agent can read.
SSH keys, credential files, shell configs.
All readable by default. The security story isn't only about execution control, it's about the whole access model.
A commenter on Hacker News put it well, sandboxing shouldn't be opt-in.
And that's the architectural question this surfaces. Security tools were designed for static workloads where the threat model didn't include the tool itself, reasoning about the controls.
So what's the practical takeaway if you're running Claude Code right now?
Enable the bubblewrap sandbox, set a narrow deny list for sensitive paths, and restrict file access to your project directory. That's the minimum. Ona's research shows even that has limits.
The tool can now think its way around the box, and the box wasn't designed for that. Thanks for breaking this down, Maya. Full bypass chain breakdown is on awesomeagents.ai.
And keep an eye on Vito from Onapanamu. They're extending coverage to network, file, and memory primitives, which is the right direction.